All right. So, kind of get started here. First things first. Um, my name is Professor Lantis. I've my fourth year teaching here at IU. I've taught introduction to applied econometrics every single semester. I was over at Ball State. If you're not from Indiana, you might not know where that's at, but I was there for 8 years. I taught a variety of courses, but a lot of econometrics. Uh, so before we dive into things, I'm going to tell you something first off, admittingly. They literally got this room ready last Friday. And in fact, when I came in Monday, they were putting up these boards, finishing touches. So I tried to, work with what was available to have an idea about what I could do today. I often like do notes with paper. They don't have a dot cam here, so I'm going to try to get into the 2026 update myself and use an iPad here in class to kind of do notes and things, but it's a little bit clunky. I apologize. I'm still kind of getting used to this system that they have set up. So before we kind of dive into things, a lot of the things I mentioned here today. So if we've got our Canvas page, I'm going to be working through these kind of PowerPoint slides. I've got the syllabus itself posted up there. I'll kind of do some summarization of that, kind of expectations for the course and the semester. And then we'll already start diving into material here today. If you have any questions at any point in time, feel free to stop me. Today is really meant to be a day where we kind of get ready and set ourselves up for the rest of the semester. Okay. So with that in mind, right? So, excuse me, there is an assigned textbook for this class, but quite honestly, I'm not like assigning anything from it. It's more of a kind of, I don't know, additional resource that if you've exhausted the resources I make available to in the class, you would kind of go to. You can probably find an older version of it. In fact, I think the fourth edition, I think this summer they came out with a fifth edition. So you can always find like old editions of textbooks for really cheap online. Or they have, some editions, this book in the libraries if you want to look at that, but you really shouldn't need it. But just kind of making it kind of known to you. Mainly everything that you'll need for this class will be anything that I do in the slides or anything that we do in class. Okay. So the Canvas page for this site is going to be very important. I post announcements on there about anything I need to kind of translate or kind of give you, transmit to you outside of class. So keep an eye out. I know sometimes it's easy when you see those in your inbox, an update or a notification from Canvas to just kind of ignore it. But I use the announcement for things that need to be, you need to see before we start the next class. Okay. What else will you need for this class? So I guess it's not technically required in terms of when you're in the classroom, but a lot of the assignments that we have in this course, you're going to need a laptop, right? Now, in terms of I put smartphone tablet up here, I'm going to use some in-class quizzes, which I'll talk about here in a second. But for those, you'll need to be able to access Canvas while you're in class. So that could just simply be on your phone. Because we're going to be doing a lot of work in a program called Stata, it's likely going to be very advantageous for you to have a laptop in class and work along with. Okay. And hopefully, are all of you supposed to be an E371 here? So I put an announcement up already on Canvas. I think it was last Tuesday I got a notification that we switched classrooms. So there may be a little bit more full in here on Thursday once people kind of realize I went to the wrong room today. Which kind of brings me to my kind of next point that I'll kind of go through later on, which is every class I start, and I try to move it so you can't see it, but I've got Zoom running in the background, right? So today, once again, I didn't have access to all of this. It looks like the audio might not be great, so I'll probably bring in a webcam or something just to record my audio a little bit clearer. But anything we do in class, anything that's on the screen or anything that I'm saying, all of that will be captured on Zoom. Right. So that becomes really important when we're using this program Stata to work with data, because you can always kind of go back and see, okay, what was the step-by-step process we used in class? Now, anything that I do on kind of my iPad, right, that's not going to be recorded. Okay. So that's kind of incentive to be in class. That's the only way you're going to get that information. Okay. So I put up a link to the YouTube page after class. And sometimes because it's a little bit later in the day, I might have to kind of get out of here kind of quick after class. I'll try to get these posted by the end of the day. So like today, I'll try to get today's posted at some point this evening. But those will always be made available instead of like using Kaltura or some of these other IU. I just have my own YouTube playlist created. Just search Professor Lantis. I'm the first name that should pop up. I've got a bunch of B251 classes, but there will be a playlist specific to this course as well. So that's where all those videos will live. When it comes to the exams, you shouldn't need anything more than a calculator that can add, subtract, divide, multiply, or like take things to a certain power, right? Squared, cubed. That's all you should need, right? So when it comes to exams, that's the type of calculator that you'll need to have. So really anything less than like even if you have a graphing calculator, I'll kind of that, but all you really need is like a basic calculator. I say 4-function here. We won't even be doing things where we take things to a lot of powers when it comes to exams. Okay. Excuse me. So in class, I don't care if that's on your phone. When it comes to the exams, you think I'm going to let you have your phone out? No, right? So you will need a physical calculator when it comes time for the midterm and the final. Okay. Also, every single week, I put up these skeleton slides. So that was the PowerPoint that I showed you on Canvas already. Now, this first week, I don't have anything missing from it. For subsequent weeks, I might leave out certain parts so that there's another incentive to be in class, right? Also, I will leave some things out. There will just be blank slides. Usually, to be honest, it's a reminder to me that I want to draw something out or kind of show you some equations up here on the iPad. Once again, that's not getting recorded. Okay. So these slides will always be posted like after Thursday's class. I'll post up the slides for next week. And in fact, I do that because if I try to do it all at once, I try to have this class move to be not so rigid. I have an idea of the outline that we'll cover, but if there's more questions on a specific topic, we might take a little bit more time on that, and it might kind of bleed over into next week. So in fact, this week I was probably overly optimistic about how much we'll get through. So that first week of slides, the last maybe 5 or 10, that might actually wait until next week, right? So I'll kind of constantly post the slides for the next week after the previous week's Thursday's class. Okay. Once again, I can kind of get rolling, especially like in a day like today where it's like very much me giving you information and not as much kind of back and forth. Feel free to stop me if you have a question at any point in time. Okay. So any questions so far? Okay. Excuse me. So what do you care about, right? How do you get the grade that you want? How are you going to be grading this class? So I'm going to have a midterm and a final, right? Those will be 30% of your overall grade, each one of them. So these are not like other classes, just not multiple choice. A lot of these are actually kind of written response, right? Or showing your work. There might be, as we get closer to them, I'll give you practice exams so you can see it's usually a mix. There's a couple multiple choice. There might be, the majority are kind of written response, right? Or kind of showing the work that you did to earn the full credit. Okay. So as we get closer to these, we'll obviously discuss them more. I'll give you practice exams, problems you can kind of work through, get an idea of what the format of these exams is going to look like. Canvas quizzes, I'm going to use these about every other week. So every like 2 weeks, we'll then have a quiz that covers those 2 weeks material. So there will be 6 of those throughout the semester, 12% of your overall grade. So you can see, not quite worth as much as the exams, and there's several of them. So each one relatively low weight in terms of kind of comparing that to the exams. But they're really good checks. And after you take them, you can't see them until the due date is passed. But once that due date is passed, you can see what the correct answers are. And those are really good problems to review. All right. Now you have access to all of your notes, right? All of the resources you don't have available to your exam. So these quiz questions should be, I should never say easier or harder points to get, but it's going to be easier to get those questions correct than on the midterm and the final. Okay. But I try to write them in a similar level of difficulty as the questions that you'll see on those exams. And I'll dive a little bit deeper in each one of these categories here in a second. We're just kind of setting up how your grade is calculated. So we're also going to have these problem sets. I'll definitely dive a lot deeper into that here later on today. But we're going to be using a program called Stata. So once again, similar, there's going to be 6 of these about every 2 weeks, where we're using this program and data to kind of go over the concepts that we've covered the previous 2 weeks. Right? In-class quizzes. So the way that I use in-class quizzes is I have Canvas, right? And what I'll do is some point in class, could be towards the beginning, middle, even the end, kind of randomly, right? Some of the material that we've been talking about in class, I will then kind of go to Canvas, I'll publish a quiz that I had ready to go, and I'll have the time set to be something like 5 to 10 minutes to complete it. Right? I'll then kind of pause, give you guys time to kind of work on these questions. And usually it's only like 1 or 2 questions. They're pretty, they're very, very short. But it's more of a way for me to give you credit for attendance. As long as you're paying attention, a lot of the times I feel very nice and I might work through the questions along with you. So as long as you're not sleeping in class, should be able to get a lot, the vast majority of these questions correct. Okay. So 4% of your overall grade doesn't seem like much, right? But if you get to be on kind of that cusp close, say I have an 89, right? If I was showing up to every single class, it's going to be more likely that my grade instead of an 89 is like a 90, right? So when I'm around those cutoffs, these kind of easier points, once again, for just simply showing up in class are going to be important. Okay. So those Canvas quizzes I already mentioned, they're about every 2 weeks. We'll have 6 of them throughout the semester. Typically, after we kind of cover the material that they're going to be reviewing, I'll post them after class on Tuesday. They're due on the following Monday by the end of the day, right? So you'll have a few days, kind of decide when exactly you want to take them, kind of review the practice problems that I'll give you. I'll give you practice problems for every single quiz, in fact, well in advance. So even before we cover all the material, so you can start looking at them early. And what else did I want to say here? I had a thought. Once you start them, you'll have 60 minutes to complete them, right? So there's no like pausing the time or pausing the clock. Once you sit down and take it, make sure you're ready. You have that time carved out. Once you start that quiz, you've got 60 minutes to submit it. Okay. So if you want to submit it by the due date and time, that means you need to start it by Monday at 10:59. I wouldn't suggest waiting that long, but technically that's what you could do. Okay. Any questions from me before we can keep moving?
Is the final going to be cumulative?
Yeah, so I would say it's not cumulative in the sense I'm not going to go back and ask you the types of questions that I'm going to ask you like next week, right? I always say my exams are comprehensive. So most courses, not all of them, but this one does operate that way, is that as we cover material, it all builds on itself, right? So we're going to use what we talked about in week 2 and 3, and we're just going to complicate it more and more throughout the semester. So we'll start talking about linear regression, essentially the rest of the semester, and linear regression will kind of come at the end of next week and the following week. We're just going to talk about different complexities we can add into regression, not just linear, but nonlinear, looking at instrumental variable approaches. So it's not cumulative, but what we learned earlier in the class, like we're just going to keep building on it. So yeah, it will just be over like that second half of the class. Okay. Any other questions before we keep moving here? Okay. Also, you can kind of see with the Zoom recordings, we'll see how this audio plays out. I'll probably end up bringing a webcam. I move a lot. So once again, it's an imperfect substitute for class, right? All of you econ majors, right? It's not perfect. It's an imperfect substitute. Because I do move around and the audio doesn't get always captured perfectly, but especially when I'm working through things in Stata, like I'll be up here, you'll get a lot of that audio very clear. I already mentioned these in-class participation quizzes. So your attendance isn't required, right? But there are points that are earned by being in class. Now, it's a relatively small amount. And I guess theoretically, you could wait around on Canvas until I deploy these quizzes and then complete them without being in class. But I can't stress enough, like if you start missing classes, to the question earlier, everything's comprehensive, right? We build it, you're going to fall behind pretty quick, right? So being in class is really important in this class. Even though I have these YouTube videos, I more so have them so that you can review. They're not meant to be viewed as a replacement for being in class. Okay. And I put some classes we won't have these in-class quizzes, but the vast majority we will. Right? And I don't announce what days those will be. The fact that they're random, right, makes it more likely you attend every single class, right? Because you don't know which one you're going to miss. Okay. So at the end of the semester, we'll have, and this is kind of, once again, I kind of keep it fluid, but we'll probably have, I don't know, 16 to 20 in that range in class quizzes. So I use them quite a bit. There's just some days where based on the material we're going to cover, I don't carve out time for them. But at the end of the semester, no matter how many we have, I'll drop your 4 lowest. So the way that I view these four lowest is essentially your personal or sick days, right? If you end up missing a class, you miss an in-class quiz, you get a 0. But I don't want to have to ask you for documentation if you had a family member die. That's not something that makes me feel good, right? But I know these things happen, right? But I also don't want to determine what exactly constitutes a reason why I can excuse, which is why I build in these 4 personal or sick days. Once you go out and get a job, if you don't show up to work, they're not going to pay you, but you could use one of your sick or personal days. Right? That's how I view these. Okay. So that's kind of, excuse me, where this is going to be coming from, or kind of what this will look like. And once again, I'll deploy these when we're in class. I'll have a test one on Thursday. The ad drop date is, so I don't like to have anything due that first week, but I'll have a practice quiz that we'll use on Thursday, so you can kind of see how we will I'll deploy them in class and how you would answer them. Okay. Any other questions before I keep moving? Also, I said you could kind of not be in class and get these. We'll see on Thursday. I give you an access code. So I guess technically you'd have to not be in class, have someone that's in class, have them tell you what the code is, right? So I got, technically you could, but it's going to be a pretty complex process if you want to do that. So we're also going to have 6 problem sets. Once again, like the quizzes, roughly every 2 weeks. Once I assign them, I try to give you a minimum of a week and a half. Usually it's closer to 2 weeks between when I assign these and when they're due. I wouldn't kind of wait, till towards the end of that due date, just because the longer you wait, the further you get removed from when we covered that in class. But they should take you a good amount of time, and given your schedule, I want to make sure you have a good amount of time to devote to these. They're typically always due on a Thursday, kind of at the very end of the day, no matter kind of when I originally assigned them. So I have a rough outline in the Word document of the syllabus about when those problem sets will be due. Once again, it's a little bit fluid based off of how the course progresses, but that's what they'll look like. And so what these problem sets will be is we're going to use this program called Stata or Stata, data. If that's a different person, they'll call it something different. But it's basically a statistical program, and you have access to it through IU Anywhere. So I think we'll have enough time today where I can introduce it to you and show you how to kind of get using it on your device, right? If not, we'll start out with it basically on Thursday. But it's a data management program where I'll give you different data sets and we'll work with them in class, but I'll give you some for these problem sets. You then use that data to answer specific or certain questions about that data. We'll start to see, how do we run regressions using this program? How do we create new variables out of an existing data set? And so, that's what those will look like. Would always be things that we've covered in class. You'll always have templates. Well, basically anything I ask you to do on these problem sets, we'll have done something in class where you have just a different data set, right? And you have the code that would produce whatever, answers to the questions I'm asking you would be. So you always have something that we did in class to be like a nice template for this. Okay. Yeah.
How will you test this on Stata?
So I'm not going to test you on it specifically. Now, what I will do is on the exams, and once again, when we get closer to exams, you'll see more. I'll give you output from Stata and then ask you questions related to that. So you're not going to have to do any I'm not going to ask you about specific coding questions or how do you exactly do this in Stata, but I will give you Stata output. So the problem sets are more of, how do I get Stata to produce what I need to start to answer other questions? The exams are more, here's what Stata would give me. How do I use that to then answer the subsequent or the kind of following set of questions? Is that what you were getting at? Yeah. No, I won't ask you exactly what's the syntax to do this. No. Okay. Any other questions before we keep moving here? Okay. Excuse me. So we've got 6 of them, 24% of your overall grade. Each one's worth 4%. Okay. So just to kind of summarize some important dates for this class, I've got the midterm and the final dates up here. I've got the withdrawal deadline. I think that I might need to change this. This was I think I accidentally put up the late withdrawal deadline. I think the real withdrawal deadline is September 27th, if I remember correctly. And then the ad drop date is up here at the end of this week. Hopefully that doesn't apply to any of you that you remain in the course. But especially, the midterm, it's in class. It'll be in this room. You all are like upperclassmen at this point. This is the time. It's different from class that the university gives us, right? So make sure you don't have any conflicts with these dates, the midterm and the final. If you know that you're going to, you need to let me know at least a week in advance. And the earlier, the better, right? In terms of kind of being able to schedule a time for you to take that exam, right? Typically, I always say the only way you can take it is if you take it early, if you're going to have a conflict. Okay. And then we would have to set up when that would be. Other than that, that should be kind of what we need to know here. And obviously, when we get close to that final, I'll let you know about what the location is. They don't usually get those out until about 2 weeks before final. So how do you be successful in this class, right? So, I put read the book here. Really, the book for this class is going to be the slides I give you. So even though you're not going to like understand it, and some of the stuff in the slides, you're gonna be like, well, I haven't talked about it yet. I don't have any idea. You just kind of skim through them, kind of get an idea, especially as we start to go further in the semester. Be like, oh, there's some of this stuff that looks familiar. Okay, this is going to be the new stuff that we cover in class. And that kind of gives you an idea, kind of primes your brain for what we're going to talk about in class, makes class more effective and efficient both for you and for me. Right? Means we can cover material a little bit quicker. We can go through more examples in class. So try to kind of look through those slides or read. That's going to essentially be our book before class, just to kind of set yourself up for like just kind of having an idea about what we're going to be talking. Okay. Show up to class, right? So I was just trying to stress earlier, like you fall behind in the first few weeks, it's just going to be an uphill battle for you to kind of get back to where you're on the same level or the same wherever we are currently in the class. Also, there's kind of easier points associated with attending class, which is those in-class quizzes. Once again, I'm usually pretty friendly in the sense that we work through a lot of them together. Practice, practice, practice. So when I give you these practice problems for the quizzes and I give you the practice exams or practice problems for the exams, I'm giving them to you for a reason. A lot of the times they're old questions that I've used in older exams. They're trying to give you an idea about what the types of questions I'm going to ask you are. And so I can't stress enough, working through these is going to be the best way to prepare for the exams, right? Now, as we get closer to them, those problem sets, especially the stuff that's not coding related. So part of those problem sets, yes, I'll have you create these variables in the code, but some of that is interpreting the output you get from Stata. Those questions would be relevant to kind of study and practice before we get to those exams as well. All right. So take those Canvas quizzes seriously. Once again, you've got additional resources available to you when you take those. And it's you have a little bit more time per question than the exams. It's not written response. It's the format of those. It's like multiple choice, fill in the blanks. There's some numerical response ones where I'm looking for a specific number, but it's nothing like where you have to show your work kind of like you will on the exam. Open notes, right? So the other thing I can't stress enough, missing deadlines, any deadline in this class, there's no like point reduction for the number of days late. If you miss the deadline, it's a 0, right? So if you submit something after the due date and time, it's a 0. Zeros, it's basically a stats class. We'll end up talking. 50% are not good, right? So if it gets to be like, oh shoot, 15 minutes, I forgot about this quiz. Let me get on Canvas and just randomly kind of fill out as much as I can. Well, even a 25% isn't going to kill your grade near as much as a 0. Zeros are really going to pull down your average grade in these quiz categories, right? Or missing lots of classes. Those zeros start counting. That's really going to start to impact your grade. Okay? So take a stab at everything, even the problem sets. You get close to the due date, you don't have time to come ask me questions during office hours, just do as much as possible and submit something, right? Anything's better than a 0, okay? Excuse me. So this brings me to my next point. Don't be afraid to ask questions. So I have a GA for this course, and their name and email address from the syllabus. I'm still waiting on them. I told them, like, I gave them this first week, see what their schedule looks like to kind of set up their office hours. So they haven't gotten back to me yet. I should have their office hours by the end of this week on Friday, and I'll get the syllabus updated and then this slide updated so that you have what their office hours are. My office hours are going to be up on the 3rd floor. I'm in room 309 from 8 to 11 on Monday, Wednesday. So I know it's a little bit early, sorry, but that's, that is what it is. That's my availability given all the other courses that I'm teaching. Now, if you can't make it during that time slot, I don't know, you only have classes during that time, you can always set something up by appointment. I mean, my schedule is somewhat, I can't, for instance, when I'm teaching other classes, I can't schedule anything with you, but we can try to find another time if you're not able to make it into office hours a specific week, where I can try to kind of set something up by appointment as well. Okay. So, right, I want to be there to help you. I get that using this data management program state is going to be really different early on for a lot of you. And, I like teaching, I like being up in front, and kind of helping people like learn, but office hours are like a lot more rewarding for me, if I'm being honest, like just to be able to work kind of one-on-one, or if there's multiple people there, usually it's a similar kind of questions. Also is like a really valuable experience for you. I think you get a lot more out of the class if you come into office hours and ask the questions that you have. Okay. So always feel free to stop by if you're, intimidated to ask things in class. This is a good time where there's not I don't know, a social cost, right, to asking what you think is a dumb question in class, right? We can remove that during office hours, right? I don't think there's any, personally, I wouldn't say there's any dumb questions. We should always kind of trying to be, even if it's like something that should be more basic, like we should be questioning basic level principles. Anyways, that's a lot of the times why we've gotten to some of these more complex models of economics, right? Because we question the underlying assumptions about our basic economic models. Okay. Any other questions before we keep moving here? I say any other. Are there any? We're going to office hours?
Like for grades, if you don't do well on something.
What do you mean?
Extra credit.
No, there's no extra credit in the class, right? It's just those that you get points for taking, whatever you get on the quizzes, the exams, your problem sets, points you get in the in-class and the quizzes. There's no additional like extra class. Yep. Any other questions?
Are you on curves?
I don't rule them out, but I base it off of what the kind of mean, median, standard deviation of those exams are. I would say if there's any curves, usually they're not huge. A few points here or there just to kind of get the average where I want it to be. But I wouldn't expect it, right? You want to act as though there isn't one, and then if there is, wow, good, right? Get a little bit higher of a grade. But if you bank on that, and then there isn't one, right? It also kind of your preparation might be less if you think there's going to be a curve. So I don't ever have like a pre-planned curve in mind. But if the mean median is below a certain threshold, I sometimes adjust it a little bit. Any other questions? Yeah.
For the quizzes, will we have like the stat printout, or will we need to run stat on our own?
No. If and the quiz and the exams, so I would like embed a picture basically into the Canvas quiz, so that you would have it in front of you. No, the only use of Stata in terms of like producing the results on your own is just the problem sets. Yeah.
We have a Windows laptop. We need to run idle thing where it says access data.
Yeah, so I'll go through the steps and stuff in more detail later on, but it doesn't matter what you have, you're going to need to use IU anywhere. Yep. Any other questions for you? Okay. So, kind of just jumping into what we're going to be doing throughout the semester is, ideally by the end of the semester, what we want to do is be able to identify what the causal relationships are between variables. So if we increase taxes, right, what is the causal effect? Do people smoke more or less, right? Well, just because there's a correlation that when cigarette taxes are high, people tend to smoke more, well, that doesn't seem to make sense. If you go back to like ECON 251, E2, we increase the price of something with taxes, it should lower the quantity that we see. Well, maybe that the government realizes areas where cigarette use is high, that's where we want to tax individuals because we can make the most money. So we might see a correlation between those two, but it's not that cigarette taxes are causing cigarette usage to be high. We need to kind of dive a little bit deeper into that relationship to figure out what the actual causal effect of taxes are. Okay? So we don't just want to look at correlations, we want to look at causal effects. I use the cigarette example, but like, do class sizes impact student test scores? Well, a lot of you might see that like lower class sizes, people tend to do better, like in terms of like high school. Well, districts that have a lot more resources financially are likely going to be correlated with a lot of other things that improve student test scores, or students coming from backgrounds where the families have access to more resources. And if you have more resources, you can hire more teachers and keep class sizes low. So even though it looks like there's an effect, and intuitively we think there probably is, right? You get a little bit more one-on-one attention from whoever the teacher is, the actual effect might not be as large. So even if it's in the same direction, might not be as large when we're just looking at this correlation in the data set. So here's some other interesting questions we can start to answer by the end of this course. Does race impact mortgage denials or mortgage rates that people are given? Right? If it does, this is obviously an evidence of discrimination. This is something we want to be concerned about. Right? Cigarette taxes actually reduce smoking. I kind of already used that one, but it starts to become like we can answer all types of questions once we understand how to work with this data in the context of any micro or applied microeconomic issue, right? So we look at things in the healthcare sector. We could look at labor market issues. We could look at things on kind of a more macro level, looking at measures of GDP and how different, I don't want to say factors, but different characteristics of countries kind of impact their GDP or impact kind of expenditures in different categories. So we can look at a variety of different issues in economics from learning about econometrics and how to work with data. Okay. Excuse me. So before I even go on that, just to throw this out there, as we progress through the semester, especially towards the second half of the class, I've had some students who maybe stop by during office hours and aren't asking questions about material, but just like they're interested in something. They find some data based off what we started talking about in class. They started doing some work on their own. That ends up being you. Always feel free to kind of reach out, stop by during office hours, ask me to kind of take a look at a project you're kind of just doing on your own. In fact, I had a student, I ran into him the other day. I kind of emailed back and forth with him over the summer. He started some project on basketball player efficiency ratings or something like that. And he found some data and I started kind of helping him. We're now kind of working on a project this semester. Now I can't I'm not say project. I'm giving him some advice. I'm not like weekly meeting, but he's kind of throwing things at me to say, okay, does this look right? I know we talked about this in class, but I want to apply this and kind of have something that he can hopefully put on a resume, at least even if it's not submitted anywhere and published, but at least it's like a project he did on his own, which shows, some characteristic that most employers are going to want, right? So you can apply it to sports, you can apply it to really whatever you're interested in. All right. So before we kind of dive into actual material here, are there any questions for me before we get started? Also, do you guys mind if I turn the lights on up here? I just realized they're off and it's bothering me. So let's see. I think this is the one if they got it set up correctly. There we go. All right. I feel like I'm in the dark. So we're going to look at a bunch of different types of data sets throughout this semester. So we'll kind of put some words to them and I'll give you some examples. So we've got cross-sectional data. So this is going to be when we're looking at one point in time, but we've got several different subjects. Okay? So this might be like I take everybody in this room and I look at what your current GPA is right now. That would be cross-sectional data. I have many different individuals and I have this variable of GPA recorded at one specific time today. Or this could be a macro level. I've got every single country. I have their recorded GDP in 2024, right? That would be cross-sectional data. Now, time series data is I'm looking specifically at one individual at multiple points in time. So maybe I select one of you and I look at what your GPA was in every single semester, right? I now have multiple time periods, one subject, that's time series data. Maybe I have one country, what their GDP was every single year for the last 50 years. Right? So it's slightly different. We're looking at cross-sectional versus time series data. Depending on the questions that we have, we'll be dealing with different data sets, but just kind of giving us like a, setting things up that we're going to look at for the rest of the semester here. We also have panel data. So we probably won't get as many examples of this early in the semester, but towards the end of the semester, we actually have topics completely devoted to this. So this is like I took time series and cross-sectional data and I mashed them up. right? So this would be like if I had every country, I had their GDP for the last 20 different years. I've got multiple periods of time. I've got multiple individuals, countries here. That would be a panel data set. Or if I had every single one of you, I had what your GPA was your first semester freshman year, second semester freshman year, third semester, et cetera, et cetera. And that would be a panel data set. Right? So you can imagine, like, which of these do you think has the most, I don't want to say useful information, but can we extract the most information from? Well, panel data is like a mashup of cross-sectional and time series. Panel data has a lot more information that makes we can start to do things with panel data we can't do with cross-sectional data. So these are the types of data sets we're going to be looking at. Just to kind of give a visual, I threw some tables up here, right? Cross-sectional is I have every single country, multiple individuals, but I only have their GDP per capita in one single time period. I could then have cross-sectional data that looks a little bit different, but it's still the same thing. I still have one point in time. I think I went back and grabbed these from 2024 was the most recent census data that I could get. And so I've got multiple different cities, so multiple individuals, one point in time, but I don't just have one, I don't have to just have one variable. I could have their population, I could have their median household income, et cetera, et cetera. So even cross-sectional data, I can have multiple variables. It's just they were recorded at one point in time for every single one of these individuals. Here I say individuals. Individuals could be cities, countries, companies. Right? When I say individual, it's really just a different entity, or sometimes in data we'll call it an element. Right? Any questions on this side here? Shouldn't be too wild yet. So here's kind of time series data. I went and grabbed the unemployment rate in the US for 2008 to 2021. I've got one subject, right? The US, multiple points in time. This is time series data. And then panel data, I had an old project, a couple projects I was working on at one point in time where I had I-STEP scores. Do you guys, you still take the I-STEP, right? Yeah. So I had like what grade they took it in, what their reading and math score was. But notice I had I don't have the names, but the student that was given an identifier of 1, I had what their scores were in 3 different years. Student 2, I had their scores in 3 different years. Multiple subjects, multiple points in time, I had these different variables collected. I've got a panel data set. So I think this is getting too old now. So 15 years ago. So yeah, none of you are going to show up in this data set. But I used to be able to say that maybe you'd show up in this data set as an number. But more recent data, you could probably go out and get. You just have to request it from the state, and it's a whole process, and it's not really worth it. But this is an example of panel data. Okay. So we'll start doing some kind of basic review. Let's see where we're at, kind of time-wise here. Okay. So how many of you took E370? Most of you, or you took an equivalent. I think that's the only way you can get into this class, right? So you learn some basic statistics, I shouldn't say basic statistics, but we're going to review some of the things that you learned in that class. I'll start out, I assume that you took the class, but I want to review a little bit of it before we kind of dive too deep into the new topics. So some notation that we're going to use throughout the semester is anytime I'm looking at what we would call population data, the total size of our population is uppercase N. That represents our population size. Okay. So this would be like if I had data, I'd have to have every US citizen, every country in the world, they're recorded, whatever variable I'm looking at, every single automotive firm, if I'm looking at kind of the automotive industry. So this would be population data. Now, a lot of the time, especially when I'm thinking about something like US citizens, if I want some information, let's say on, what the savings level of every single individual are. Well, I'm probably not going to be able to get that for every single person, but I might be able to get it for 100 people or 1,000 people or even 10 million people. But 10 million is not the population of the United States, right? So that we would kind of call sample data, right? But population data would be every single individual. Now, if I'm thinking about something like going out and grabbing test score data from Indiana schools, if I think about the different values I could see, right? So let's say this is a test from 0 to 100. I could go out and see that this specific school had an average score of 79 and this other one had 84, right? Well, I know that if I was just to select one school at random, it's much more likely I see something around 70 or 80 as opposed to like a passing rate of 0, right? So I know that different outcomes will have different probabilities associated with it if I'm just selecting one of these observations at random. Okay? So anytime we kind of have this variable where we don't know the outcome, it's a random variable. If I just select one observation, I could see a range of different values. We'll think of this as a random variable. And we want to start to calculate the mean, median, other statistics for these random variables. Excuse me. So when I'm thinking about that there's different values and they have different associated probabilities, we can then think about every single value I could see for this variable I'm interested in. Maybe it's the average, test score of a school. It's going to have every single value has a different probability associated with that. I could draw this out as a distribution, right? So this gets a little bit clunky sometimes if we only have what we call discrete variables. So here, when I'm looking at math scores, the way that these are reported, they're not reported as like 342.9, right? They're only at the integer, or they might only put them in bins. Sometimes when you go out there and look for data, you might see if I was wanting like the average income, or I want to look at income values, sometimes it's not reported as like a specific dollar amount. It's that person's income was in between 20 and 30,000. So even though I can still look at what that distribution of the data looks like, here instead of every single value, maybe it's like a range of 2 to 3 points. This is the probability associated with it, or the number of times that I see that value pop up for this variable divided by the total number of observations I have. So every single kind of outcome for this math score variable, I have an associated probability, right? What that gives me is my distribution, right? The distribution of the different outcomes I could see for this random variable y. So if it is discrete, I don't look for what's the probability. Sorry, we'll do this in a different way. If it is discrete, so what does discrete mean? It means that I can only see like integer values, or I can only see everything from like 100, 200, 300, right? There's jumps. I can't see anything in between. That's a discrete variable. So if that's the case, I can find the probability of that random variable being equal to that specific number. Now, if I'm looking at truly continuous data, right? So if I had truly continuous data, right? I can't actually find the probability of any one value. I can only find the probability that the random variable, if I selected one observation at random, that it's in between two values. So maybe doing a little bit of a review, hope maybe you remember this from 370. Why can't I find the probability of one specific value if it's a truly continuous variable?
It's so insanely small. The percentage of you picking that exact number is near 0.
Yeah, so if we think about it, if I could see any number, 325.67912345, all the way out to whatever decimal I wanted, that's a truly continuous variable. How many values could I actually see? I have a trick question. It makes things really weird. Infinite number. So if I have an infinite number, the probability of seeing that value essentially becomes 1 over infinity, which got to go all the way back to some more math courses. What does that end up being in the limit? 0, right? So we can't find the probability of one specific value from a continuous variable. We can only find the probability, unfortunately, of it being in between a certain range of values. Okay. So that makes things a little bit harder for us to deal with. Some of the early examples we'll be dealing with some discrete data, so that'll be okay for us, right? Where are we at in time? Just a second. I'm like going over. So some other notation stuff we want to kind of remember is I'll use a lot of summation signs when we start looking at the actual formulas. So just as kind of a reminder of what that means. So if I have a summation sign and I say kind of start with 1 and go all the way to 5, right? So if I have the summation of 2 and I want to start once and go to the 5th, that means take this value and add it to itself 5 times. Right? So 2 plus 2 plus 2 plus 2 plus 2. Now, what's likely going to be the case is we don't just want to add up the same number, certain number of times. We're going to say, okay, I've got this data set, right? Maybe I had the number of classes that all of you are taking. So I have each individual, I have the number of classes you're taking. If I want to know the total number of classes being registered for in this classroom, I would want to take the number of classes you're in, plus the number of classes you're in, plus the number, right? So on and so forth. So what I'd want to be doing is taking this random variable y. I don't know how many classes, if I chose one person at random, that they're in, but I would want to take every single person, starting with the first, and then add up how many classes they're in, this random variable y, going all the way to the very last person. Or what was capital N? That was the number of observations in my population, right? So that's kind of what our summation sign means. And that's where if we have this random variable, we're not adding up 2, right, over and over again. I'm adding up whatever that random variable's value is for each observation I would have in my data set. Okay. So just kind of a review of that summation sign. We'll be using that the whole semester. It'll pop up a lot, right? So what are some other statistics that we often want to look at when we're talking about variables? And here I'll initially start out thinking about variables. We'll then kind of translate this into random variables, where the probability of seeing different values has different associated probabilities. Okay. So here, if I'm looking at the mean, right, that's typically what we lazily call the average, right? There's actually different averages we can calculate, but the mean is one of them. What I would do is I'd go through every single observation, right? Take the value for that random variable, add that up for every single observation. So back to my earlier example, maybe I want to know what the mean number of courses being taken in this classroom is. So I'd add up every single person's number of courses. I then divide by total number of people in this room, right? That would give me the mean number of courses being taken by people in this room. Does that hopefully sound familiar? Okay. What about if this is a random variable? Well, there, I don't have every single observation. It's not like I have every individual. I only know the probability associated with seeing a student taking one course. And I know the probability of a student taking 2 courses. So to find the mean of a random variable, right, what I would do is I'd go through every single possible value for that random variable y. I would then multiply it by its associated probability. So I'm not selecting individuals, but maybe say, what's the average, or what is the kind of mean number of courses being taken by IU students? I could look at some consolidated data and say, well, I know that the percent of students taking one course is 5%, or the probability, we got to get used to doing this, 5% would be a probability of, oh no. If I want to go from a percentage to the decimal form of a probability, I take that percent and I divide it by 100. Right? So 5% is 0.05, 10%, 0.1, so on and so forth. So I'd go through and take that number, right, that value of 1, multiply it by the probability I see a student only taking one course. My example, I had 5%, that probability would be 0.05. And then I said, okay, I'm going to add to that the next possible value I could see, which is 2. Right? Students taking 2 courses. If I selected a student at random, what's the probability they're taking 2 courses? Maybe it's 15% or a probability of 0.15. So I would take 1 times 0.05 plus 2 times 0.15. I then kind of do that all the way through. I don't know the highest number of courses as students. Hopefully it's nothing more than like 7 or 8. But I would go through every single possible number of courses, every single possible number I could see for this random variable y, multiply it by its associated probability, and then add them up. So this is kind of a review as well. So here I was dividing by the total number of observations in my population. If I'm looking at a random variable, here if I think about every value as representing 1 out of n, right, or 1 out of the entire population. Here the probability is out of what? What's the total probability? If I added up every probability of every possible outcome I could see for that variable, they should add up to 1. So dividing by 1, I can ignore it. We want to be very technical. I should have divided by 1 here, but it's always going to be 1. Okay? So this is how we would calculate the mean. We're also going to talk about the median. Really, the median, we kind of treat this in a slightly different way. We won't dive into it with discrete random variables. For anything we do in this class, the median, we're just going to calculate as though it is a continuous variable. All we're going to do, and it doesn't have to be continuous, it's going to be discrete. I just mean it won't be a random variable with probabilities. What we would do is essentially the median gives me 50% of the observations on the right, 50% of the observations on the left, or 50% are below this value, 50% are above, right? So what this looks like in terms of a data set, if I had every single person in here and I had your GPAs, to find the median, I arrange them. I then cross off the lowest, cross off the highest, cross off the next lowest, next highest, all the way until I get to that very last observation that's exactly in the middle. Now, if it's an odd number data set, there will be one value left. If it's an even number data set, I'll have 2. So what do? Whatever those 2 observations in the middle are, I essentially add them up, divide by 2. I find the mean of those last 2. Right? That's how I would get my median in that example. Okay. Once again, hopefully this is sounding familiar from whatever stat course you took before this, right? And then the mode, right, is simply the value that occurs the most number of times. So if this was a discrete random variable, what could you say about the mode of that random variable? It would be the value that has the highest, that happens the most frequent or the most often, it would have the highest probability, right? So if we're looking at a random variable, that mode, well, it's not the number of the value that shows up the most because I don't have every single individual. I only have the probability associated with seeing certain values. So if I was looking at the mode of a random variable, it would be the one that has the highest probability associated with it. Okay. And this is where I'm talking through some of these things that aren't in the slides. This is good things probably to take notes on. If I mention, if you're thinking about what should I take notes on, you always have the slides available to you. So why take notes on the bullet points in the slide? Probably take notes on the things that I'm kind of adding in or I'm saying. Okay. Good. And then kind of some review. The variance. What are we doing? Well, I've got a summation sign. So I'm going through every single observation. I'm subtracting the mean. So we call this, what term have you heard from other stats courses? This is the how much this observation varies or deviates from the mean. So I will often kind of say, this is the deviation of this individual's value for whatever variable y we're looking at from the mean. I'll then take that deviation and square it. So why do we square it? Well, if my value is only 1 away from the mean, what is 1 squared? 1. But if I'm 2 away from the mean, so only 1 unit further, what is 2 squared? 4. So the further I get from the mean, squaring it really over penalizes values that vary a lot from that central point of the data set. So I would do that for every single observation, then add up those deviations from the mean squared, and then essentially the variance is like, what is the average deviation from the mean squared? Because what do I then do? I divide it by the number of observations I have in my data set, or here, the population. Okay. The standard deviation, right? I'll come back to this here in a second, is just the square root. We're just scaling the variance, right? And we'll see why this becomes more useful probably already on Thursday when we start to talk about calculating test statistics and thinking about confidence intervals. But we often kind of scale that variance to what we call the standard deviation by taking the square root. Now, if this is a random variable, how do I find the variance? Well, I still go through and I take the deviation of every possible value I could see for y from the mean. So I take that deviation squared, but what's the likelihood I see that deviation? Well, the likelihood I see the value for this random variable y take on a specific number. So this is like if I selected one of you at random, what's the probability that your age is 20? Well, I mean, I don't know that off the top of my head, right? I would say, okay, take 20, subtract the mean age, but then what's the likelihood I see that individual be 20? Whatever the probability of being 20 for an IU student in Econ E371 would be, right? So I would take the deviation squared, and now I have one more step, which is multiply it by the probability I see this variable y take on that value. Once again, I'm still really dividing by the sum of my observations, but my observations now are essentially probabilities or the total number of observations. So this should always be 1. So we don't have a denominator here when it's a random variable. Any other questions before we keep moving here? Or any questions, I should say. So where are we at on time? So we've got what, 20 minutes left. So I think we'll have enough time to work through this here. So, got 20 minutes. I think we'll have enough time. If we don't, I might truncate this example early. So if you go to Canvas and you go down here, this is generally how I'll have the class structured. So I have like week 1, here's the materials we're going to use. I got the PowerPoint slides, the syllabus. I'm going to use this Excel data set. Okay. I then usually have like assignments. So I'm going to post this after class today. It's a background survey. I think I have the due date set to be at the end of the day on what, the 27th would be Thursday. Just it's not for any points. I just want to get more of an idea about kind of what your interests are, what your class is in terms of like what freshman, sophomore, junior, senior, some other additional information that just helps me direct the course and just know a little bit more about what the makeup of this of all of you looks like. So I'll post this after class. It's not an assignment for any points. It's just something that will kind of help me get a better idea about you guys. Right. I'm not going to look at any one person's specific answers. It's more of I want to know what the collective total of the class looks like. So I'll always kind of have assignments for the week. And then I'll also kind of have this whatever Stata files we're going to use. So here, this isn't a Stata file. We're not going to use this. I just want to show you this. Sometimes I'll show you first examples how we do things in Excel. It's still a data management program. And then we'll kind of see, okay, how do I do this more complicated like in Stata? So for us, just so I don't have to write all this out to make it pretty complex, we can kind of do all this in Excel. So I've got this IU football data. We'll go here, make this a little bit larger. Is this too large? No. Right. So I've got this. I took IU football for the last 5 years, and I had the total number of possible wins. I left out 0 because there was never a 0, and I don't know. I guess technically they could, but to make it easier, I just left it out. Right. So here's the number of wins, and here's the number of seasons they had 1 win. Here's the number of seasons they only had 2 wins, et cetera, et cetera, et cetera. Right. Last year was kind of an anomaly, right? And so here I've got the different number of wins, and I could kind of go through and say, okay, I've got the frequencies. How do I turn those into probabilities? If I know I've got 25 years and they had 5 wins 6 of those years, how would I get the probability?
You just divide each of the Y column by 25.
Yes, 6 over 25. Right? So all I would do to find this probability if all I had were frequencies. So here's like my random variable Y. What's the probability that it's equal to? In this case, we could do, I don't know. So what's the probability that this random variable Y is equal to the different values for this random variable, right? Well, I would just take the number of times that value occurred, and I'd divide it by the total number of observations that I have, right? Which would just be adding up those frequencies. Now, in Excel, once again, we won't use this a ton, but just to kind of, I will walk through some stuff in class. If you're not super familiar with it, don't worry, I'm not going to have any parts of the assignments that are related to Excel. It just makes us doing the math a little bit quicker and easier sometimes in class. So if I want to kind of copy this down very quickly, I want to take each frequency and divide it by 25. However, if for some reason I add data in later, this number could update. So I'm going to use the cell reference. If I want to freeze that cell reference, when I drag this down, I just use $signs. So if you see some of the completed Excel files and I'm throwing $signs in there, it's so that it can be created much easier. Instead of entering this in for every single row, I can enter it in once, right? Now, when I copy this down, I've got the probability associated with every single possible value for that random variable Y, which was the number of wins in a season. Any questions? You want to see anything there again? I can kind of go back to the cell I had. We good? Okay. So if I'm thinking about, if I want to calculate the mean here, it's a random variable. So what did we say we needed to do? We needed to add up whatever the value for that random variable was times its associated probability. So here what I'm going to do is I'm going to say, okay, take the number of wins, essentially the value for that Y variable, and multiply it by the probability. So I'm going to take 1 win, the value for Y, multiply it by its associated probability. I'm then going to copy this down. It should update, oops, not too far, update all of my cell references. So I'm doing that for every single possible value for y. We then said to find the mean, I would use that sum function to essentially add these all up for me. Oh, this is going to be weird because this keyboard's weird. All right, so I'll add up all these values. That should give me the mean number of wins for IU football over the past 25 years. Okay. And if this looks weird, I left out like the college championships on the side. This is any questions on how I calculated that mean there? Okay, so what if I instead wanted to do the variance? So there, what do I need? Whoops. I need the deviation from the mean squared. Right? So what I'm going to do here is I'm going to say, okay, take that value for that random variable y. I want to subtract the mean. So I could put the value in, but once again, if I added data, I want to make this so that this file would automatically update. So I'm going to say, take that mean. I always want to use the mean, so I'm going to freeze that cell reference. I'm going to square that deviation from the mean. Okay. I then want to do this for every single possible value I could see for that random variable y, which is the number of wins. So I'm going to copy this down. I then have the deviation from the mean squared for every single one of these possible values. Now notice, if the mean is 4.56, those values that are close to the mean, they're not very far, right? So what ends up, the deviation from the mean squared is going to be a much smaller value, right? Whereas values that are very far from the mean, those deviations from the mean squared start to become rather large, okay? Excuse me. Any questions on this before we get one more step, which is I have the deviation from the mean squared, right? So what is the next thing that I need? I need to add them all up, right? So if I add all these up, that should give me the variance. Okay. Any questions on that? So this is just me doing math quicker than I can do by hand, right? Now, what if I wanted the standard deviation? What's the only thing that I need to do? Take the square root of my variance. Okay. So we could do this by hand. You know, it just take us a little bit longer, right? I might ask you to do some of this by hand on the first quiz, but I won't give you this many values. I give you like 3 or 4 just to make sure I know you know how to do the concept, right? To work this out by hand. You know, technically you could use Excel while taking that quiz if you felt comfortable doing that. And we'll review this a little bit more. I'll kind of have some stuff where I write it out on Thursday just to kind of review how we're calculating the mean, the variance, standard deviations. Next class, the covariance, right, by hand. Okay. Any questions here before we keep moving? Excuse me. Okay. Also, I just want to make a point here, just to kind of, let's say I ignored these probabilities, and I know that this random variable could be anything between 1 and 12. So if I find the mean of these values, what we'll end up seeing is, well, they all have different associated probabilities, but if I just ignore those, well, it looks like the mean number of wins should be 6.5. Well, that's because I treated all of these the same, whereas like I never see 9 and 12, but I see 3 and 4 a lot more often, right? So you almost think about when we're finding the mean of this random variable, in some ways it's similar to like a weighted mean. The weights are just our probabilities, okay? So this is just kind of a nice example. Hopefully we're doing some review of statistics that we've already seen. Okay. So I think I'll take the next, hopefully like 6 minutes. We'll at least just introduce data. I want to kind of set you up how we start to get this down. So I've got some instructions that are a little more detailed. I'm going to walk through this today and we'll kind of pick up on this on Thursday's class. But essentially, to get this program so that you can use it, you should all have free access to it. I'm going to go to one.iu. I'm going to go here and I'm going to search IU anywhere. You guys use this for other courses? Some of you are nodding your head. So I'm going to select this. Usually it'll be prompted here to like sign in. So I'm going to sign in with my account here. I usually make a mistake typing that quick. So today must be a good day. I had enough caffeine. So once we get in here, so one thing that I've already got is this Citrix workspace. It's already on this computer. If you try to open this and it says it needs you to download Citrix workspace, you'll have an additional step, right? So I put up a YouTube video that's already out there. So if we go to YouTube, we go to Professor Lantis, right? My happy smiling face. If you go to the playlists, you find this section. Nobody wants to listen to that. So this is the only video that should be there. This is basically a walkthrough, and I was using a device where like you had to walk through every single step where it's not pre-downloaded. So you might have to download a thing called Citrix, right? And it's very easy. And anything that you do in these steps, always use your IU credentials, your IU email address and password. Otherwise, we can get some real technical issues, right, for you to use this program. So once you kind of go through, if you want to use this as a help, you'll have to kind of often ask you to download Citrix. But once you get that downloaded to your device, sometimes you'll have to enable it. When I got here this morning, it was already downloaded, but it'll ask me to enable it on Google Chrome. So there, I've got this pinned to my homepage, but you'll probably have to go to apps and then just search Stata, and it'll kind of come up with Stata now. I would put, if you want to pin this to your homepage, you can kind of click that star, just a nice, easy way where you don't have to go through the apps every single time. It then should open it up. And it opened it up on my other screen over here, but it should look something like this. Okay. Now, if you're having any issues with this, sometimes depending on your device, it won't pull it open what looks like a new window. It'll open it up as a tab. That should be okay. It's always just, it's a little bit device specific what it looks like. But more often than not, it'll pull open like this. I just know that I think it's like tablets and things like that. It'll open it up as a web page. And I will say, if you're using like a tablet, it's going to be a little bit limited. We'll actually run into some problems later on in the semester. There's only so much you can do on the tablet interface. So try to find a laptop or a computer that's available to you to kind of do the work here in Stata. But that's how you get it downloaded. Just use IU Anywhere. Once again, the additional step might be you have to kind of download that Citrix program, but it's pretty straightforward. You just use your IU credentials and shouldn't be a problem. So if you're having any issues getting to this point, to this step, reach out to me as soon as possible. Start working on this today if you have time, right? Making sure you can at least get the program opened up to look something like this, okay? So the other thing that you would then need to do is, okay, I want to go and I want to open up different data sets, okay? The problem is if I go to open here, I can access on this device my OneDrive. If you don't already have it set up for other classes, all Stata can do, because you're using like this shared license, it's technically coming on the cloud or whatever, it can only access your files from your OneDrive, right? So what you'll need to make sure you also have, oh gosh, well, that's okay. I don't think we need that for the rest of the class, so we should be good. You'll need to go to IU Anywhere, search cloud storage. You'll log in with your IU credentials. So we'll kind of do that here. Now you notice mine has a little green check mark. All you have to do to get that, instead of deauthorize, there will be an option here that says authorize, right? So you have to go to cloud storage, make sure that it kind of has access to your OneDrive for IU. Now, when you have Stata open, you should be able to open up files from your IU OneDrive. And that's where you're going to want to take any of those files I put on Canvas, create a folder on your OneDrive and call it like E371. And then maybe subfolders if you want, but you need to put all of those data files that we're going to start working with, you need to put all of them into your OneDrive in order to be able to access them. Okay. So that's what's important now, is being able to go on IU Anywhere, download Citrix if you didn't already have to have it for other courses. Make sure you have your cloud storage essentially authorized, and then you should be able to open up files. If we go back to Stata here, I could go File, Open, and if I've downloaded these Stata data sets, and we'll talk about the difference between those and do files next class, but I had some old COVID data, I should now be able to open that data up, and we'll talk more about next class. There's then different icons. I can now see the actual data itself. So all I want you to make sure you do before Thursday's class is be able to kind of get to that window where Stata pulls open, but also authorize your cloud storage and try to take one of those .dta or those kind of Stata files I have on Canvas and see if you can get it to open up here. That makes sure your cloud storage is working correctly. And if you can go back and look at this video, but that starting Stata video that's currently up on the YouTube playlist is another really good walkthrough. In fact, I go a little bit further than we did today, things that we'll kind of start with on Thursday's class about how we use this program. Okay. Any questions for me there? Like I said, we'll dive deeper into how we actually use this program to work with data on Thursday. I just want you to kind of make sure you're getting this set up as soon as possible. Okay. So the other thing that I want to make sure we go through today. So walk through this. Oh, I didn't select this time. There we go. All right. So this course moves very quick, right? I spent a lot less time in this class in the syllabus than I did for my introductory micro class, right? So we're already kind of progressing in the material. Everything builds on itself. We're going to be going very quickly initially. Now, everything we kind of cover initially, we're just going to keep building on it, all right? So it's very important that you're not taking this first few weeks and kind of thinking that it's no big deal. Even though we're doing review of things you might have already learned, I'm sprinkling things in there, specifically how we use Stata. Right? That's going to be a really important component early on in the class, something I doubt most of you have seen before. Okay? You know, I don't expect that you guys are going to have any information or any knowledge on a lot of the things that we're going to talk about this semester. So there's going to be a lot of things that like just feel very foreign or alien here, right? That's okay. I expect that. Okay? And I'm going to try to teach according to that. Okay? You know, I'm going to throw a lot of stuff at you, right? So the old adage is feel like you're drinking from a water hose, right? I know this, and I try to get feedback from you. I said earlier, I try to teach the course fluidly, where I don't have a very rigid schedule in mind in terms of what I cover in class. I kind of go through things quicker as I get fewer questions, things I get more questions on, we spend a little more time on. So I'm aware of this, right? And I know that this might be, especially using Stata, very daunting and feel like a lot at first. Okay. It's okay not to understand things, right? Once again, I expect this. This is why, please, please, please stop by my office hours and ask questions if you have them. Work through all those practice problems. Come by and answer, stop by and ask questions if you have them, right? Start working on things early because you're probably not going to understand stuff in Stata forever, which is why I have a very long period of time in which it's open. Because if you just start at the last day, you might get stopped at square one, right? But also, you guys are still in college, right? Like you got to find a work-life balance, and it sounds very cliche, and whatever. I want to get all the best grades ever. You're only in college once. Like I miss the hell out of it, right? So make sure you're having like some find something you enjoy, have some fun, and try to get a good balance so that you can actually be if you study too much. There's diminishing marginal returns. Theoretically, they could become negative if you keep going, right? You've got studied so much, I can't even keep track of things in my brain anymore to kind of give you an econ kind of language. Other than that, yeah, this is my 2-year-old son. So I'm exploiting his cuteness so that he hated me after the first 60 minutes of this, or whatever, 70 minutes of this class. Maybe I can personalize myself a little bit. So try to make sure you can kind of get Stata kind of going on your device. I'll dive into some actual Stata examples on Thursday, start working with some data sets. Otherwise, technically my office hours don't start till next week, but I'll be here from 8 to 11 tomorrow morning if you want to stop by. Otherwise, hope you have a good start to the semester, and I'll see you guys on Thursday.
Thank you.
Yep. Thank you.
All right.